Hello everybody. My name is Şaziye. I am an assistant professor from Boğaziçi University, Turkey. I am working at the Institute for Data Science and Artificial Intelligence. Well, a little bit about me. I actually work on natural language processing, and my current research focuses on NLP of low resource languages. And with my colleague Esma, we wanted to contribute to this, we want to participate in this workshop by annotating a named entity recognition dataset for NACBA narratives. So I'm going to talk about this dataset today. So as you all know, Nakba means catastrophe in Arabic, and it refers to the displacement of Palestinians for more than 75 years. Since there are lots of Nakba events, and it holds high importance in many aspects, like cultural, historical, and in legal aspects. And we wanted to create an NLP resource from these Nakba narratives, because although it is a very important series of events, it is not highly represented in NLP. So we wanted to contribute to this field in Turkish language. And there are different types of sources for Nakba-related narratives, of course. But the main source of narratives in Turkish language comes from news content. So we focused on the news that mention Nakba events in the last year. So we wanted to create this data set in Turkish language because there is lack of representation of Nakba narratives in Turkish. So our main objective is to create a named entity recognition data set for Turkish, because named entity recognition is like the first step to extract information in a text from a corpus. And you can also use these named entity tags to extract relations between entities, and you can do sentiment analysis on these contents. So we wanted to create a NER dataset for Turkish the sources comes from Nakba narratives. For this aim, we scraped news articles from the two biggest news agencies in Turkey. One is Anadolu Ajansı, AA agency, and the other is TRT Haber agency. So we collected 369 news articles, but we filtered some of them because we wanted the news only include witness testimonies in them. So we filtered the other news that do not include witness testimonies. So the final source of news articles are 181. After that, we started the annotation process. The annotation process includes two steps. The first step includes automatic annotation. So we used a BERT model, a BERT-based model to automatically tag the sentences, the entities in the sentences. And then in the second step, we manually corrected the errors by the BERT NER model. So in the first step, we utilized BERT. It has a BERT architecture, and it is pre-trained on Turkish text. And then we utilize this model that is fine-tuned on a large Turkish named entity recognition dataset. Actually, this dataset is also the source of this data is also news, Turkish news, but these news are like from 20 years ago, so the context is not the same, of course. So we take this NER model and give our sentences to the model to predict the named entities, person, location, and organization entities in the sentences. And actually, the model achieved a pretty good score, F1 score of 87% in predicting the named entities. The location and person scores are actually high. But the thing is, the precision is very high in detecting the entities, but the recall was lower in all types. So this indicates that there are named entities that the model cannot detect. And after this step, we applied the manual annotation process. So the predictions of this model, Bertrand model, was corrected and verified by 2 human annotators, basically me and my colleague Esma. But there are challenges in this step. Actually, the segmentation and tokenization errors that occurred while we preparing the news data in CONL 2003 format. There are lots of segmentation and tokenization errors because of the sources the news come from. And the manual correction requires significant effort in that step. Also, another challenge was reading all the sentences, testimonials line by line, and trying to annotate them without crying. That was also another challenge because these were really devastating. Anyway, the inter-annotator agreement between human annotators are measured as 0.96. We use Cohen-Kappa score. We measured this inter-annotator agreement score on 100 random selected sentences. And since the score is very high, then we divided the remaining sentences in half and annotated them manually. Here is a sentence from the data set. This is a CONL 2003 format. So here we have the doc ID, which shows the source, the URL of the news. Here we have a metadata that shows the date and hour that the news is written. We have sentence ID, and the text, the annotated sentence here. So this is in Turkish, of course, but I included the sentence translation in English. When we annotate the named entities, we use this B and I prefixes that shows the beginning of the entity, beginning token of the entity, and the intermediate tokens of the entities. So this is actually for multi-word entities. And if the token is not an entity, we denote it with this O, which means other. So yeah, and after these annotation steps, we reach a total number of 4,000 sentences in the dataset, annotated sentences. And in that dataset, we have 2,000 and almost 300 person entities, almost 6,000 location entities, and 1,300 organization entities. We also made some analysis on the dataset to see if we can extract some meaningful relations between entities. So our initial attempt is to print the co-occurrence graph of the entities in the data set. So we did this for TRT Haber section of the dataset and AA agency section of the dataset separately. But this is TRT Haber, I guess. Basically, we just count the number of times an entity occur with another entity in the same sentence. And for demonstrational purposes, we only show the most frequently co-occurred entities here. But even in this graph, we can see that there are some related entities that is printed near. So for instance, always, and BM is the Turkish abbreviation of United Nations, UN, and Lazarini and UNRWA. I don't know how to pronounce it, if there is a word for it. Yeah, and this is for the AA section of the dataset. We also printed this location mentions frequency over time figure in TRT Haber News and AA News separately again. And here you can see in the x-axis the location names like USA, West Bank, Beit Hanun, Beit Lahia, Jabalia, etc. And in the y-axis we have the dates. This is like the beginning of the genocide, and this is I think the latest date that we collected the news, 2024, at the end of 2024. And from this graph, we see that, for instance, in the end of the 2024, there are high mentions of Jabalia, Beit Lahia, and Beit Hanun. And when we look at the graph for AA News, we again see that at the end of the 2024, the same locations, Beit Lahia and Jabalia, are mentioned more frequently than the others. For instance, here, around June 2024, there's high mention of Sedat Zaman detention camp, and yeah, Rafah from these figures. Yeah, to conclude, we created a new NER dataset for Turkish Nakba narratives. Since we can consider Turkish as an underrepresented language in NLP, it just contributes to another dataset in Turkish NLP. You can reach the dataset in this link. As future work, we are planning to expand the dataset. We want to include more news and more entity types, and we also want to annotate relations between entities. So we want to make this dataset cover relation extraction and also sentiment analysis tasks. So thank you. This was all from me.
Thank you so much, Batul and Asma, for your presentation. It's so insightful to see this analysis and the data set. The whole work is very important. I will I will give the opportunity for questions and answers from the audience if they have any.
Okay.
Yes, Mustafa.
Yeah. Thank you, Batul, for this presentation. We actually also work on named entity recognition in my research group, but in Arabic, not in Turkish. So also for Nakba. So my question to you is, how do you consider cases where Turkey is a location and Turkey is an organization? So because the annotation can be or should be context specific or context sensitive.
Yeah, we talked about this with my colleague Esma and made some research on it and look at some famous NER data sets and see that in such cases the country names were always annotated as locations. So we did not make the difference like Turkey as an organization, Turkey as a location. We all like in sentences, Turkey said that something blah blah. Then we again annotate Turkey as location.
So it's all the time location.
Yeah.
Yeah, but when I say Turkey said, Turkey did this and that, I don't mean the location. I mean the
Yeah, we just follow the path of largest data sets and annotation styles of large data sets, and yeah, this includes some ambiguity. Yeah, you're right.
And can you elaborate? So I have another question. So can you elaborate more on the future work? You said you want to extend this to also add the relationship extraction. How are you planning to do this? Because we are also doing this, but for Arabic. Yeah.
Actually, I didn't work on relation extraction before, but that should be the next step, I guess. Maybe linking the entities to a knowledge graph first, and then annotate the relation types and between entities. So it should be like intra sentence, right? And that would be a pretty good thing to have in this data set because to extract more information from these narratives. And we also want to label the sentences as negative, positive, and neutral for sentiment analysis. Yeah.
Thank you.
Thank you.
Thank you, Mustafa. Is anyone else has any question for our speakers? If not, I would like to ask a question about the accessibility of data and the transparency of the transcribing. You mentioned that you did manual annotation. Can you tell us more about the challenges that you faced while also doing this, and in terms like of how the Turkish language and NLP models can be very challenging to do this type of work? In terms of, like English is the most common language in these models. So what other challenges that you faced? You didn't mention the presentation.
Actually, we, as I said before, we used an automatic annotation as the first step. So we use this Bertrand model that is fine-tuned on a very large NER data set in Turkish. But there were some consistent errors that this model made during the annotation, during the prediction. Like in the past, there was a political party called Refah in Turkey. So it always labeled Refah in Gaza as an organization. So we should always we should have corrected the organization to location, etc. So there are some such consistent errors that the Bertrand model did. Also, since Turkish is an agglutinative language, so the suffixes are added at the end of the words. So one single word can have lots of hundreds of different word forms when these suffixes are added, and this challenged a little bit the model. So the errors are coming from that part. And I think if we measure the partial entity matches in the predictions of this model, it would be higher. But since we wanted exact matches, like there are many multi-word named entities in the data set, the model predicts part of the entity, but it should be a whole entity, multi-word entity. So we need to correct the prefixes, annotate the other entities, etc. So that was another challenge. Yeah, I think the most important ones are these.
Thank you so much. I think every language is different, but there's also like the concern of transparency and how the accuracy of this data while running these models